Hello everyone, you are all welcome to lecture number 937, and today's topic is the chemical reactions and toxicity of pesticides. Actually, when these pesticides are applied, it has adverse and toxic effect and some chemical reactions. And mainly the chemical reactions are because of its two factors. First, the concentration of pesticides, and second, its toxic effect to man. So once the concentration of pesticide is more, and if it is more toxic, definitely the man who is using will be adversely affected, and sometimes it may act as poison. And as you know that all these or most of these pesticides, and individually we call them insecticide, herbicide and fungicides, they are organochlorinated hydrocarbons. And these chlorinated hydrocarbons, they are itself toxic, and their toxic reaction starts first that it may go in vapor form, and once they are in vapor form, they can be changed into CFCs, that is chlorofluorocarbon. And these chlorocarbons and chlorofluorocarbons, they are responsible of lot of environmental and atmospheric hazard, and in upper layer of atmosphere they can even destroy the ozone layer by knocking down the oxygen. Also, these pesticides, when it is applied on soil and with the colloidal nature of soil, these pesticides are absorbed, and once it is absorbed, these pesticides are decomposed and their degradation will take place, and sometimes they may stay for a long time. And when these pesticides they are staying for a long time, it can cause some effect to soil fertility. So in this way, it can go to that level that even up to deep in the soil. And also these pesticides, sometimes they are in liquid or solution form, and they can escape to water from the soil, and the water is also contaminated because of pesticides. So that's why there are a lot of chemical reactions of these chlorinated compounds which are escaping in atmosphere in the form of CFCl, and also they are retained in the soil and they are toxic to human beings. So all these one by one I am going to discuss. So the reactions and toxicity of pesticides. And number one, pesticides can contaminate groundwater as the soil soaks rain and irrigated water. The presence of pesticides in groundwater is a matter of grave concern, because pesticides cannot be filtered out by making use of filtration techniques. In addition, if contaminated groundwater is used for irrigation, it can be a potential source of toxicity for crops, and crops can be polluted. So it is a very grave concern, very serious issue. One, the groundwater, they are contaminated with pesticides, and they can pollute the crop, as well as they can make the seeds and grains toxic. Number two, when pesticides are applied in soils, they undergo following types of chemical reactions. A, pesticides and chemicals may vaporize and may be escape to atmosphere. They can be vaporized, and they may escape in the atmosphere, and once they escape in the atmosphere, they can knock down some hydrocarbons and they can recombine and they can form the chlorofluorocarbon. And that chlorofluorohydrocarbon, I have already told you that it is responsible of depleting or making the ozone layer thin, and that may cause the health hazard, because once the ozone layer is thin, there is chance of penetrating of lot of ultraviolet lights. And it is the ozone layer which is protecting as a shielding layer to filter out the ultraviolet light to reach the Earth's surface. So to the atmosphere with chemical change. B. Pesticides may be absorbed by soil colloids. C. Pesticides may move down through the soil in the liquid or solution form and be assimilated in soil by leaching. So by leaching process, sometimes they are assimilated with soil and they can go down. Then D. Pesticides may undergo various chemical reactions within the soil environment or on soil surface. So even if it is on soil surface, these pesticides, they can undergo different type of reactions. E. Pesticides may be degraded by soil microorganisms, and with that degradation, these pesticides can be in different chemical structures. The toxicity of pesticides are associated with its residues depend mainly on two factors. One factor, that is concentration or level of residue, and second, the toxicity to humans and other life form. During application, some of the pesticides fall on the ground. Even when we are applying the pesticides, sometimes it is very easily escaping from our hand, it is falling on the ground. That is also affecting the soil fertility on the ground, contaminating the soil. The pesticides are detoxified in the soil by adsorption and degradation, and their presence in the soil for a long time could adversely affect the fertility of soil. So number 3, as we know, chlorine is the basis for many of the most toxic synthetic chemicals known. So all these synthetic chlorochemicals, they are all very toxic. It's well known to everybody. And chlorine tends to combine with hydrocarbons to form organochlorines. And this tendency of chlorine to combine with hydrocarbon to give monochloro, dichloro, trichloro, tetrachloro, hexachloro, all derivatives, they are all highly toxic, persistent and bioaccumulative. For example, organochlorines are dioxane, DDT, 2,4-T, PCBs and ozone depleting chlorofluoro compound, that is CFCs. Their effects on humans include cancer, reproductive and development impairment, effect on liver and kidney functions, a neurological impairment, and a number of other health problems. In general, wastewater treatment does not detoxify or destroy organochlorines. Rather, they bind the particles and either travel to the final disposal area or volatilize to air. So these chloroderivatives or organochlorohydrocarbons, they are so much resistant to the detoxification that they are not detoxified, rather than they will combine with those waste material, and again recycling will be there, and from where they are ultimately redeposited on the ground or in water. So out of that recycling, again they will come and they will be either redeposited or they will be on ground in water. Number 4, although many organochlorine pesticides have been banned since 1960s, in 60s, the current use of DDT in developing countries exceeds the past levels of its use in developed countries. The pesticides like DDT, dibromochlorophane, that is DBCP, indane, dieldrine, and heptachlor are proven tetratogens. So with this I will stop. Thank you very much for watching the lecture.